Assalamualaikum warahmatullahi wabarakatuh. In this opportunity, I will present our work, which is the reusable electrode of EMG sensor for capturing the calf muscle activities. My name is Rizka. I am from Barelang Robotic and Artificial Intelligence Lab at Polytechnic Negeri Batam. So this is our outline. First, I will talk about the introduction and then the hardware configuration, the experimental result, and close by conclusion and future work. So this is our motivation. The first, as we know that the common use of electromyographs or AMG sensor to record the muscle signal activity is using the gel electrode. However, for the sensitive skin, it may cause irritation, and also the gel electrode need to be replaced or add some gel in period of time. So this is really inconvenient if this electrode was used to record the muscle activity signal in period of time. Therefore, we presented the reusable electrode which can be used in several times without adding some gel or even changing the pads by attaching a conductive fabric on the stretch fabric material as the substitution of gel electrode. So our related work based on the Pilatuk et al., which they present a comparable result to the commercial electrode in long-term monitoring. So they did some experiment to collect their muscle signal from the arm, and they used the 5 different types of electrode, which is the electrode gel, and the polysilicon-based electrode, and also the textile electrode. So from the experiment, a textile electrode made from conductive yarn, it delivered a good signal quality as long as the electrode was saturated with electrolyte dilution. So our problem statement is how to construct the reusable electrode of the EMG sensor to record the calf muscle activities, and also how to make the reusable electrode as comfort as possible when the user wear it, and how to record the muscles activity signal when the user walk on the flat floor in the real-time application. So this is the hardware configuration. We attach the conductive fabric here on the stretch fabric material. This is the stretch fabric material. The dimension of this conductive fabric is 7.5 centimeters in width, and also 6.5 centimeters for the length. And the distance from these two clips electrode, which is will be connected to the myaware sensors. In here we use the myaware sensor from the spark fan. The distance is around 9 centimeters, and the distance from each conductive fabric is 1.5 centimeters. And myaware sensor also need a reference signal from the conductive fabric on the other side. So this is the configuration. We put 4 centimeter times 15 centimeters of the conductive fabric to the other side of this stretch fabric material. So this is the electrical design of the reusable EMG. We use as I said before, we use the myaware sensor from the spark fan, and we connect it to the Arduino here, and then we monitor to the PC by using this USB cable, and also to collect the output signal from the myaware sensor, we did the filter here, which is bandpass filter, to filter the raw rectifier signal from the myaware sensor inside the Arduino Nano. And here is the experimental result. So after they wear the reusable electrode and the gel electrode at the same time, they will walk on the floor with the normal speed, and then we recorded the signal activity from our PC, which is sent by the Arduino. And then in this experiment, we want to see the signal generated by the sensor in the stance phase and swing phase. So if we can see the rectified signal here, this two is a rectified signal from the reusable electrode, and this two is from the gel electrode. As we can see, the differences of these two signals is the reusable electrode can be distinguished in every step of walking, which is swing phase and stance phase. In each walk, it can be generate a different kind of signal, like swing phase in below and the stance phase in up signal, and also swing phase in below and the stance phase in up. And if we do the bandpass signal here, the signal will be like this, and the swing phase also at the below of the signal, and the stance phase at the upper of signal. This is different with the gel electrode, which are the swing phase in this area and the stance phase in the up, but at the second step here, the swing phase and stance phase generate the same signal. So this is really hard to distinguish which one is the swing phase and which one is the stance phase if we wanted to use it for the, the, the other device such as exoskeleton. To compare the reusable electrode and the gel electrode, we collect the voltage generated by user A, B, and C, and which can be seen in this table. So from the data, we can say that the reusable electrode can be generate a voltage or a signal as better as gel voltage signal, because every person have a different types of muscle. So maybe user A can be generate a good signal of the reusable, or maybe the others have a good signal in the gel voltage. But from this result, we can say that the reusable electrode have a quality output signal as better as the gel electrode. So this is our conclusion and future work. At first, we developed a reusable electrode for AMG sensor by adding the conductive fabric material on the starch fabric, and the reusable electrode is placed on the cuff of the human body to collect the activity muscle while the user walking on the platform. And the experimental results given the proof that this device able to detect the cuff muscle signal activity in every walking phase precisely as better as the common electrode gel of the AMG sensor. However, it's still limited to the certain cuff diameter, so that in the future we will develop the reusable electrodes which can be used in various different of the cuff of the human body. So this is the end of my presentation. Thank you for your attention, and wassalamualaikum warahmatullahi wabarakatuh.